So number 22 on the left-hand side has cotangent squared. And y'all know this textbook, this is your second year with this same textbook publisher. Y'all know the problems just keep getting harder and harder. So these will just get harder to verify. So on the left-hand side, I have cotangent squared in the numerator, cosecant in the denominator. Then on the right-hand side of the equation, I have cosecant of angle t minus sine of angle t. I really, most of the time, try not to choose the side that has plus or minus. I like to start with something else. And again, sometimes that's not the easiest thing. Sometimes you'll start on one side and you won't go anywhere and you'll have to erase and maybe think again on that side or maybe go to the other side. But on 22, I started on the left-hand side and I broke up the left-hand side into cotangent squared times 1 over cosecant squared. And you really don't have to write this step, but since these are notes, I'm just trying to show you how I'm thinking. So I rewrote it as cotangent squared times 1 over cosecant squared. And then, like I've done several times, I turned everything into sine and cosine. So cotangent squared. Cotangent squared. Just forget about the squared for just a minute. How do you turn cotangent into sine and cosine? Okay, so cotangent is cosine over sine. So cotangent squared would be cosine squared over sine squared. And this is not the only way to do this one, but I can verify by turning everything into cosine and sine. So if you have a cotangent squared, you can change that into cosine squared over sine squared. 1 over cosecant would turn into sine in the top. 1 over cosecant is equal to sine. The reason it's helpful to turn everything into cosine and sine is because things will then start to cancel out and you can start to simplify that side down, hopefully down into the other side. All right, do you see anything that could happen at this point? Okay, you could cancel your one sine in the top with your sine squared, but then you would still be left with just a sine. Alright, so now I have cosine squared over sine. Now I start to look at the right-hand side and I realize somehow I've got to get two terms. Somehow I've got to get two terms and they're going to be subtracted. So that's kind of a clue there. Does anybody see I can take something that I have now and turn it into two things that will be subtracted? Cosine squared, I can use my Pythagorean identity, sine squared plus cosine squared equals 1. And if I solve that for cosine squared is going to be equal to 1 minus sine squared. So I used one of my Pythagorean identities there, and I'm still over sine. So I've got the minus in there. I've just got to get a cosecant. I got to get a cosecant minus a sine. Anybody see what we can do in the next step? We can divide everything in the top by sine. You can't just cancel the sine with the sine squared and not divide the sine into the 1. But if we rewrite this by dividing everything by sine, we have 1 over sine minus sine squared over sine, which is just sine, because the sine in the bottom cancels with the sine squared in the top. So what you did is you took that fraction, you divided everything in the top by sine. So 1 divided by sine is 1 over sine. Sine squared divided by sine is just sine, and then you almost have it. Last thing that you do is Turn 1 over sine into cosecant. And then you've made the left-hand side turn into the right-hand side. All right, your quiz is Wednesday. So we have today. Tomorrow is all review. You got a worksheet. You're going to verify all block tomorrow. And your quiz is on Wednesday. And again, there's all kinds of different ways to verify. There's not just one way. I can't show you all 10 ways in each example. I've just got to show you some different examples. Okay, questions about 22. All right, 24. We have 1 over sine theta on the left divided by cosine equals secant theta minus cotangent theta. This one's pretty short. We can actually use something that we just did in number 22. And on the left-hand side, we can break that up into 2 separate fractions. And we can divide everything in the top by cosine. So you're going to end up with... What's your first term you'll end up with when you divide everything in the top left by cosine? 1 over cosine minus sine over cosine. Does everybody see that? If you have something in the top divided by something in the bottom, you can break that up into 2 terms. You just have to divide everything in the top by what's in the bottom. And then once you look at the right-hand side, you see you have to have a secant. Well, you have a 1 over cosine, so you can turn that into secant. And then you have to have a cotangent. Well, you have a... Did I write the problem down wrong? Yes. I was going to say, that's not going to work. This is supposed to be tangent. Ooh, good. I was going to say... All right, and then you have a tangent, and sine divided by cosine is tangent, so you'll just turn that into a tangent. All right. Let me try to step back and y'all see if you can't get this one started. Do you have any ideas? Do what?
We can start with the left and do like the tangent and cotangent. Make them sine over cosine, make them sine over sine.
Okay. All right. All right. So either in your head or on your paper, you've got to realize that first term is sine times 1 over tan. Some of y'all can just see that. Does everybody see that very first term is sine times 1 over tan? So you might skip that step and you might go ahead and say that's really sine times cotan. And some of you might even skip that step and you might in your head go, hey, that's 1 over tan, which is really cotan, and cotan is really cosine over sine. So I can't really say, there has to be X amount of steps because I know some of you will do part of that in your head. And then the second part, this cosine over cotan, that's really cosine times 1 over cotan, which is really cosine times tan, which is really cosine times sine over cosine. So we could kind of skip all the way down here if y'all caught on to what I was saying, and we'll have a plus here. You'll have that cosine. You'll have 1 over cotan, which is really tan, and tan is really sine over cosine. So I am perfectly fine with you skipping steps if your brain can do that. If your brain can't do that, then you need to write your steps in. So then what happens? Yep, your sines will cancel and your cosines will cancel, and you'll end up with cosine plus sine, and it's okay to change the order that we add. We know that addition is commutative, so you could go ahead and write that as sine plus cosine. You want it to make it look, you want the one side, you got to make that one side look exactly like the other, so you wouldn't want to end with cosine plus sine. You'd want to end with sine plus cosine. So again, if you're noticing, a lot of these can be verified by turning the problem into sine and sine and cosine. All right, let's see if we can get something that's a little bit different here. 28. All right, 28 is different. Let's look at 28. I've worked 28 a couple times, and I've got, hey, this is a better way. Again, sometimes we just may take the long way around. Just depends on how our brain's thinking through the problem. All right, so this one's a little bit harder in my opinion. All right, so I've taken the left-hand side and I worked it one way to begin with, and then I thought of an easier way, but we probably wouldn't do anything on the right-hand side because it's just too simple and we don't have a lot to work with. So we would start on the left-hand side. So one of the things that I want to show you is anytime you have 1 plus cosine, or 1 plus sine, or 1 minus cosine, or 1 plus sine, when you don't have a cosine squared there, you can't really use the Pythagorean identity. Y'all know sometimes we can use 1 minus sine squared. Okay, we don't have a cosine squared there. Okay, so there is a little algebra that I can do. Okay, if I have a 1 plus cosine, or a 1 minus cosine, or a 1 plus sine, or a 1 minus sine, there's a little algebra that I can do there. And you might remember something called a conjugate. So what we're going to do is we're going to keep the cotangent for just a minute. Or actually, we can turn that into cosine and sine. So what's cotangent going to be equal to in terms of cosine and sine? It's cosine over sine, so we can go ahead and do that. All right. Anytime you have 1 plus or minus cosine, 1 plus or minus sine, we can actually take that fraction and we can multiply by the conjugate. So the conjugate of 1 plus cosine, anybody want to guess? What's the conjugate of 1 plus cosine? It would be 1 minus cosine. We're actually going to use a little algebra here. We did this in Algebra 2 when we had a radical in the denominator and we needed to get rid of that radical. So we really don't want 1 plus cosine to be in our denominator. So that one fraction, I can multiply the top and the bottom by its conjugate, which is 1 minus cosine. And let me show you what happens here. We still have our cosine over our sine. In the top, we have sine of t times parentheses, and we're going to use parentheses because we have a binomial here, 1 minus cosine. And then on the bottom, since I have conjugates, I can do the first terms being multiplied together. 1 times 1 is 1. So 1 times 1 is 1. Cosine times negative cosine is negative cosine squared. So if you multiply conjugates together, 1 plus cosine, 1 minus cosine, 1 plus sine, 1 minus sine, you're going to end up with something that we can replace by using one of our Pythagorean identities. So 1 plus cosine times 1 minus cosine turns into 1 minus cosine squared, which then turns into what? 1 minus cosine squared is really sine squared. So the reason I'm multiplying 1 plus cosine times 1 minus cosine is to get 1 minus cosine squared. Okay? And then 1 minus cosine squared turns into sine squared. All right, so bring down your cosine over your sine. Something happens. What simplifies in the right-hand part of our problem? You can cancel the one sign in the top with the sine squared in the bottom, and then you'll just have a sine in the bottom. And then I'm going to bring this down and show you what we have. We have 1 minus cosine in our numerator. In our denominator, we have sine. This is the hardest one that we've done so far, in my opinion. Okay, so the sine in the top cancel with the sine squared in the bottom, and then you had 1 minus cosine over sine. Now, we're adding two fractions, and you can only add or subtract fractions if you have a common denominator, and we do have a common denominator, so we're going to add those two fractions together. So we'll just write that as one fraction with a common denominator of sine. So we'll have cosine of angle T plus the second numerator, which is 1 minus cosine. Then what happens in our numerator? The cosines cancel, and then I'm left with 1 over sine, and then 1 over sine turns into cosecant. Yes, and you'll have to make a common denominator. We'll probably run across one of those in just a minute. Okay? And I'm going to keep saying this. There's more than one way. That was actually a better way than I had tried to begin with. Most of this is algebra. Once you use your identities, your quotient identities, your reciprocal identities, your Pythagorean identities, the rest of it is algebra. It's canceling, it's adding fractions. All right, so using this one using 28, 30 is going to be similar to 28, so let's see if you can take what we did in 28 and you actually think a little bit more and me not do this one completely on my own. All right, so this one is similar. The author of your textbook does a good job of kind of taking a technique that you're using and applying it to several different problems. All right, let's see if y'all can walk me through this one. Which side would you pick? Okay, you're going to pick the left-hand side. Nothing much on the right-hand side to work with. And using something that we did in the last problem, what would you want to do? Okay, anytime you have 1 plus sine, 1 minus sine, 1 plus cosine, 1 minus cosine, we could actually get rid of that denominator or change it into something that's easier to work with by using a conjugate. So what would I multiply by? 1 minus sine. All right, that's going to give me 1 minus cosine squared x times parentheses 1 minus sine of x. And then what will I have in the denominator? One minus sine squared x. And I intended to get 1 minus sine squared x so I could change it into something else. So what can I change that into? Cosine squared x. And that's helpful because the cosine squareds cancel, And you're left with 1 minus parentheses 1 minus sine of x. Then again, you're just using algebra. What would you do next? All right, and you would get 1 minus 1 plus sine of x. Ones cancel and you just get sine of x, which is the right-hand side. Another way to do this one is, you said, would you ever have to find a common denominator? You could actually go back to the beginning and you could find yourself a common denominator and write this as one fraction. But I've noticed my students struggle with that a little bit. They seem to like multiplying by the conjugate. It also works. Okay? All right, let's see what other one that we might want to do. Let's jump to number 34. We have cosecant squared times secant equals secant plus cosecant times cotan. So I picked the left-hand side probably because the right-hand side had 2 terms that were being added, and I usually don't go to the right-hand side. So y'all see anything that you could start with on the left-hand side? All right, somebody over here said you could turn cosecant squared into 1 plus cotangent squared. And why do you think that is a good thing to do? And why do you think that would be better than turning everything into sine and cosine? Or even the right-hand side has a plus in it, right? So if you turn cosecant squared into 1 plus cotangent squared, that's going to end up giving you something plus something, because you can distribute the secant there. Does that make sense? So because the right-hand side had the sum of 2 terms, then it would make sense to turn cosecant squared into 1 plus cotangent squared. All right, then you can distribute your secant. So secant times 1 is secant of x, and then secant times cotangent squared is secant of x times cotangent squared of x. So that gives us something plus something, and part of it's right. Part of it has secant already, right? So we're good with this part, right? We just got to somehow get secant times cotangent squared into cosecant times cotan. Any ideas how we do that? How about turning secant into 1 over sine, and turning cotangent squared into cosine squared over sine squared. So we're really just working on the right-hand side here. Yep. Oh, good job. Secant is not 1 over sine, it's 1 over cosine. I would have realized that because nothing would have canceled. Now what cancels? One cosine in the bottom cancels with cosine squared in the top, and I just get cosine. So our secant is good. Anybody see how we're going to get that second part into cosecant times cotan? How many signs do I have on the bottom? I have a sine times a sine. So I could take one of those signs and put it underneath the 1. And then I would have cosine over the other sine. Does that make sense? So if you have 1 times cosine in the top and you just have a sine squared in the bottom, you could take one of those sines from your sine squared and put it under 1. And then you could leave cosine over the other sine, and then 1 over sine turns into cosecant. They're starting to get harder. So we already had the secant of x, and then the 1 over sine turns into cosecant, and the cosine over sine turns into cotan. All right, seniors, we're finishing up our notes. I've got this on video. We're on number 34. We're going to do a few more examples, and we're going to take our identities quiz. All right, so seniors, y'all can pick up with number 36. You can pick up with number 36. The rest of these you can get on Canvas from the video.
Did you skip 32 on purpose?
Yep, I'm skipping around. So if you're just coming in, I've passed out their notebook quizzes. They're already in iNow. Y'all can check your grade in iNow on your notebook quiz. If you have a question about it, you can ask me. We've pretty well been sitting here for a while. We've been working notes for about 15 minutes. We're not going to have a notebook quiz this week. We're going to have one notebook next week. That'll include last week and this week's work. So we're verifying identities. Tomorrow is a review day for verifying identities. This is something that you have to try on your own. The whole quiz is verifying identities. So you'll have all day tomorrow to practice. I think juniors have a meeting, but you're in here today, so it'll work out. All right, so in number 36, I took the left-hand side.
Would not just be negative 1 equals negative 1?
Negative 1 equals negative 1. How do you figure?
I don't know, it's just the same on both sides, but positive and negative.
Yeah, but you got cosecants and secants on one side. All right, this is something else that a lot of people think they can do. They think they can cancel here. Why does that not work? Don't do that, but that's why does that not work? Yeah, those are really binomials. You got cosecant minus secant in the top. That's really a binomial. You got cosecant plus secant in the bottom. You can't cancel a binomial unless you have another binomial that's exactly the same. So that's illegal. I can't do that. But I could turn everything into sine and cosine. If you can't think of anything else to do, pick a side and turn everything into sine and cosine and work with it. Work with it from there. So I'm going to pick the left-hand side. Cosecant turns into what? Come on. 1 over sine of x. Secant turns into 1 over cosine on the bottom. Cosecant turns into 1 over sine of x. Secant turns into 1 over cosine of x. And then we're thinking algebra here. This is not a good fraction because it's got fractions inside of fractions. So you had this Algebra 2 teacher that taught you how to cancel out fractions that are in fractions. Anybody remember? You could, if you factored a negative out of the top, you would get secant x minus cosecant x. I wish it could be that easy, but you could never get the same exact binomial on the top as you do in the bottom by factoring. Okay, so what I did is I multiplied both sides by cosine of x. So maybe I'll just tell you what I did, and you tell me why this would be helpful. Why do you think multiplying the top and the bottom by cosine of x, why do you think that would get us closer to the right-hand side? Because what? Okay, my cosines of x's will cancel, and I'll get a minus 1 on the top and a plus 1 on the bottom. What else will happen? Because you're not just multiplying times one, cosine times 1 over cosine, you're also multiplying cosine times 1 over sine. So what would happen when you multiplied cosine times 1 over sine? You get cosine over sine, which is cotangent. So can y'all kind of see what's happening here? So when you multiply cosine times 1 over sine, you get cosine over sine. You can go ahead and turn that into cotan in your head. You're going to multiply cosine times 1 over cosine. The cosines cancel out and you get minus 1. So the top turns into cotan x minus 1. Then in the bottom, cosine times 1 over sine gives you cosine over sine, which is cotan. Cosine times positive 1 over cosine. Cosines cancel and you get plus 1. All right, let's look at one that has some factoring in it. And I am skipping around here. Let's see. 47. What was that one? 36. 36. 40. Let's look at 52. This will be the last one that we do. This one has some factoring in it. We've not factored a lot. So I'm going to choose the left-hand side, and I'm going to choose the left-hand side because the right-hand side has a 2 times cosine squared, and I don't have any identities that I have memorized that have anything to do with a 2 cosine squared. If you have memorized one of those, and you wrote it down wrong to begin with. So that 2 is just not speaking to me right now because it's not got anything to do with my identities. Okay, but the left-hand side is what we call the difference of 2 perfect squares. So don't write this down, but let me bring back your memory. If you had something like x squared minus 25, how does that factor? X plus 5 and x minus 5, because that's how we factor the difference of 2 perfect squares. So that's a simple example of something more difficult that we have, but we do have the difference of 2 perfect squares. So that's going to factor into 2 binomials. Since you have a sine to the 4th, then you're going to have a sine squared times a sine squared. And since you have a cosine to the 4th, you're going to have a cosine squared times a cosine squared. One is a plus and the other one is a minus. So sine to the 4th minus cosine to the 4th factors. Okay, and the reason that is helpful is because that gives us some sine squareds and some cosine squareds. And this first one is actually a Pythagorean identity. What is equal to sine squared plus cosine squared? A 1. So you can replace that with a 1. Makes the problem simpler. Okay. So we have 1 times sine squared minus cosine squared. That's really just sine squared minus cosine squared if I multiply everything times 1. Now look at where we're trying to go. At some point, once you start working, you got to look back at that other side and it will give you some clues. So one clue is that there's no sine squared in the right-hand side. That's one clue. So you got to get rid of the sine squared. The other clue is that you don't just have one cosine squared, you have 2. So that clues me that I want to change sine squared into something. What's equal to sine squared using my Pythagorean identities? Good. So I'm going to turn sine squared into 1 minus cosine squared. I'm turning sine squared into 1 minus cosine squared, and then I bring down that other cosine squared. Then the 2 cosine squareds will be considered like terms. They have understood coefficients of negative 1s, so I could combine those together. That first one actually stays. You bring down the 1. The 2 negative cosine squareds combine to be negative 2 cosine squared of angle T. Sine squared needed to go away because I had no sine squared on the right-hand side. So sine squared needed to go away. I replaced that with 1 minus cosine squared. So I had sine squared. I replaced it with 1 minus cosine squared. I substituted 1 minus cosine squared in the place of sine squared. Then I had 1 minus cosine squared minus cosine squared. Those were like terms. Combine them. Okay. Please, 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 please do your homework. Your homework is 21 through 41 odd. You have got to practice some of these on your own. Your homework is 21 through 41 odd. You're also going to do a few of the harder ones, 47, 51, and 53. We'll go over questions from your homework tomorrow, and then you're going to practice verifying for the rest of the block, and Wednesday is the verification quiz. Same page, page 594.